Hello everyone, my name is Cabrera. First of all, I would like to thank the organizer for this opportunity and thank you for attending this presentation. In this occasion, I'm going to present our work in investigating generative neural networks models for building pest insect detectors in sticky trap images for the Peruvian horticulture. Pest insects are a big problem in horticulture. Almost 40% of the production is lost by pests, and in most of cases, the most used pest control strategy is indiscriminate chemical control, which implies possible damage to the environment and people. So early detection is key for their control. Sticky traps are an inexpensive way to obtain insect samples in crops, but identifying them manually is a time-consuming task. Building computational models to identify insect species in sticky trap images is therefore highly desirable. However, this is a challenging task due to the difficulty in getting large set of training images of these pest insects. In this work, we study the usefulness of three neural networks generative models to synthesize pest insect images for augmenting the training set and thus facilitate the induction of insect detector models. The models used were the conditional deep convolutional generative adversarial network, Wasserstein generative adversarial network, and variational autoencoder. We trained these generative models with images from the yellow sticky trap dataset and others obtained with web scraping, for a total of 7 different pest insect species relevant to the Peruvian horticulture. The original dataset was extended with traditional data augmentation techniques in images like random horizontal and vertical flip, random rotation, and color jitter. In the first row, you can see the images generated by the trained models, and in the second row, you can see the images they were trained on. Each trained generative model was qualitatively and quantitatively evaluated on its ability to generate realistic insect images and the variabilities of the target species. For the qualitative evaluation, we applied the TSNE technique over the synthesized images and the original ones to find two-dimension representation. We can visually appreciate that the model Wasserstein and variational autoencoder seems to have learned closely the distribution of the original image set. All separated clusters and overlap clusters in the original set are also reproduced in the synthetic sets generated with that models. The dissecant model seems to have had difficulty learning the variety of the images in most species, since it tends to produce very similar images for each species. This problem is known as mod collapse. For the quantitative evaluation, we calculated the universal divergence between two distributions of TSNE embeddings, the original images of a big insect species against the model-generated images of the same species. Lower divergence values mean that the distributions are closer. The table shows the resulting divergence metric for each insect species and generative model. These results suggest that variational autoencoder and Wasserstein have similar capabilities to capture the distribution of the original images, being the variational autoencoder model slightly better, as evidenced in the average divergence. With the images synthesized by the trained generative models, we reconstructed yellow sticky trough images. Original images are also considered to be placed in the resulting images using a mixing radio. Changing this mixing radio, we define 6 different datasets to evaluate the impact of the use of synthesized data, from 0 to 100%. With these datasets, we retrain the model YOLO version 5 in order to compare its performance. To evaluate this, we use the metric area under the curve precision recall in testing data. We evaluated this metric per species. The table shows the AUC metrics of the models trained with 6 different datasets and for each species. We can observe that in 5 of the 7 species, the metric improved when we use a fraction of the synthetic data in the training sets. In some cases, the increase in performance has been more than 14%.